Now, this is the problem we have before us. We have to prove that um, sine sine theta to the power of 4 minus cos theta to the power of 4 plus 1 multiplied by cosec square theta gives us 2. Now, generally, when you are required to make a proof, usually you try to rewrite the expression such that possibly try to rewrite the right hand side expression to give the left hand side, or rewrite the left hand side expression to give the right hand side. So in this context, we have our left hand side, which is this expression equals to our right hand side. In this context, our right hand side is 2. So obviously, the simplest way to go about this is to rewrite the left hand side and see if you can simplify to get a 2. So let's get on with that. First, we have sine to the power of 4 of theta. Now, minus cos to the power of 4 of theta. Note that we can rewrite sine to the power of 4 can be rewritten as sine square theta with a square, minus this one also can be written as cos square theta all squared, then plus 1. We have this whole expression multiplied by what? Cosec square theta equals to 2. This expression can be written as this. But for the sake of the fact that we want to prove, we are going to keep this left hand side first, this right hand side first, and we'll deal with this left hand side and see if we'll be able to get 2. Now, observe that this is difference of 2 square. And from basic algebra, you know that when you have difference of 2 square, let's say you have a squared minus b squared, this can be rewritten as a plus b times a minus b. So meaning this expression, sin square theta all squared minus cos square theta all squared, can be written as what? Can be written as sin square theta, can be written as sin square theta plus cos square theta times sin square theta minus cos square theta. Okay, then we have a plus 1. This whole expression is multiplied by cosec square theta. Okay, let's go up a little. Then um, from the basics, we have learned that, recall that sin square theta plus cos square theta is 1. From here, this whole expression sin square theta plus cos theta can be reduced to 1, so that we have 1 multiplied by sin square theta minus cos square theta plus 1, everything multiplied by cosec square theta. Now, you can expand the brackets. 1 multiplies all through here. We simply have sin square theta minus cos square theta plus 1. Okay, everything multiplied by cosec square theta. Okay, now also from this same um, identity that we used here, if you look closely, you see that this sin square theta plus cos square theta, if we make sin square theta the subject of the formula here, we have sin square theta can be written as minus cosec square theta plus 1. What does that imply? It implies that this minus cosec square theta plus 1 is exactly equals to sin square theta. So which reduces our expression to sin square theta plus another sin square theta. Everything multiplied by cosec square theta. And sin square theta plus cos square theta, obviously that gives us sin 2 square theta, right? Everything multiplied by cosec square theta. Also, another interesting identity is that cosec cosec theta is actually inverse of sin theta, right? So consequently, it implies that cosec square theta cosec square theta will be 1 over sin square theta. So from there, we can now have we can now have we can now rewrite this as what? We can now substitute this here so that we have 2 sin square theta multiplied by inverse of sin square theta. Of course, this reduces to what? This reduces to 2. So we have been able to show that our left hand side, which is this expression, is exactly equivalent to what? Equivalent to 2. So that is the solution to that question that we have.